Hi guys, welcome to 4.3, Properties of Logarithms. Sorry. We're going to see how the log laws are used to transform log expressions. The first log law we're going to look at is actually useful. It's the change of base. We use this one when we have a little bitty base down here on the word log, and we don't have the ability in our calculator to put that subscript. The calculators in the classroom, you would use the alpha button, then the window button and choice 5, and it has a little template. Or if you're using something like Desmos or something like that that doesn't even have the template, then you would use change of base, which is basically any base of logarithm you want to use. So I could use log base 2 or log itself or ln of the argument over the little bitty base. Now let's see what that means in practical terms. Let's say I want to put in the calculator log base 5 of 18, but I don't have a little subscript button. Well, I'm really to the point, I just like to use the log button. You could use ln, you could use anything, but I'm going to use the log button because I know where that is on the calculator. So log of the argument divided by log of the base. Typing that into the calculator will give you 1.796. That's it. All I'm doing is changing the base from base 5 to, in this case, base 10. Let's try it again. Again, all I gotta do, I don't have a button for the calculator for the subscript, so I can use the log button. How about we use the ln button this time? So ln of the argument over ln of the base. Put this into the calculator, and I get 5.392. So it's a nice way to change from one base to another. Now, log laws. These are like exponent rules, but for logarithms. What they say is if you have if you have any arguments multiplied together with the word log in front, you can split them apart with a plus sign and add them. Or if you have a plus sign, you can put these together with one large log by multiplying the arguments. Goes the same for division. If you have the word log with a division, that's this guy, you can split that apart into more than one word log with a minus sign. Or if you have the minus sign, you can smush those together with a single word log and a division. And then the one that's the most important, I think, out of all these is the power rule. What this one says is if you have an exponent, you can bring it down in front of the word log, or if you have a number in front of the word log, you can bring it up as an exponent. So we're going to practice these log laws with condensing and expanding log expressions. So our first example. We have log of 2x cubed y to the 4th, and we want to expand it. Expand means we want a bunch more word logs. If that helps you any. So I'm going to look at this and I say this is 2 times x cubed times y to the 4th. So that's times. That means I'm going to pop it apart and separate it with plus signs. So that's what I'm going to do. I'm going to take the word log of 2 plus the word log of x cubed plus the word log of y to the 4th. So I popped it apart with plus signs. And then I'm going to use the power rule. Anytime I have an exponent, I'm going to bring it down to the front of the word log. So I'm going to look see if there's any exponents. Well, the first one, the log 2, there wasn't an exponent. So my answer is log 2 plus. The next one, I have a 3, so I can bring that 3 down. Log of x. See how the exponent just moved in front of the word log? Plus, bring down the 4. and that makes log y. So expanding, it's a form of like simplifying your problem. All it does is it takes what you have and expands it. It takes the word log multiple times. You pop it apart. If it's times, you add them. If it's divide, you subtract them and bring down any exponents. So it's kind of a two-step process. Step 1, pop them apart. Step 2, bring down exponents. All right, here's another expansion. I've got the word ln of the square root of x plus 5 divided by y squared. So what I saw was this divided by. That means subtraction when I expand this. So I'm going to do ln of the top, which is the square root of x plus 5, minus ln of y squared. Now, I have a square root, and I don't know if you guys remember this, but the square root is the same thing as the power over root, or the half exponent. And that comes from this being 1, this being square root. So what I'm going to do is I'm going to rewrite this one step as ln to the x plus 5, or ln of x plus 5 to the half. That way I have some exponents to bring down. Remember, you pop them apart and then bring down exponents. So my final answer is a half ln of x plus 5 minus 2 ln of y. So what I did is I popped it apart with a minus. The square root, I noticed that square roots, I know that's a half exponent, so I just went ahead and changed that and then brought down the exponents in front. Now, condensing is the exact opposite of what we just did. You have everything popped apart, and you want to put it back together with a single word log. So my goal is to put it all back together, or smush it back together. So I do the opposite. I'm going to bring up any exponents first. That's numbers that would be in front of the word log will become exponents. So I have the log of x squared minus the log of y cubed plus the log of z to the half. Okay, so I moved up all my exponents. Now what I'm going to do is I'm going to start popping all this stuff together. So I'm going to write the word log, and the base is 10 because it didn't have any base on it. And I'm going to start putting them together. The first one I see is minus. That means divide. So I've got x squared divided by y cubed. And then I have a times because I have a plus sign. So times means times z to the 1/2. There we go. We got him. All I did was smush it back together with a single word log after I brought all the exponents back up. Now, one thing that you may see is, since this is my math lab, they may notice that that half exponent up there, they may want you to write that as a square root. So it'd be x squared, the square root of z, because that's what the half exponent is, over y cubed. Those mean the same thing, but it does. I don't know if that's something that they would make you do or not, but just want you to be cognizant of that, just in case they ask you is how to write your answer in a certain form. All right, now an application. We got the Richter scale here. ln of I minus ln of I naught over ln of 10. R is the magnitude, I is the intensity, I naught's the minimum intensity, and they want us to write this as a common log. Wow, that's a lot of words. Well, first thing I notice is it wants the word common log. Common log means log base 10. So I'm going to start with change of base formula, because these are all ln's. These are not the common log. Well, my change of base formula for this guy here, that's log of I, that's the argument, over log of E, because ln is base E. Now I'm going to do my next guy. That's this one. So minus log of I naught over log of E, because ln is base E, over, now I'm going to do this guy, log of 10 over log of E, again, because ln is base E. Okay, so I kind of did that. Now I've got a whole bunch of log E's. Oh, but this is something I can deal with, because right here, these are the common denominator, log E. So I can put those together over the same denominator. So equals log of I minus log of I naught over log of E. And then my bottom is going to stay the same. Log of 10 over log of E. Now, I'm hoping you all guys notice that these log of E's, they're the same denominator, so they cancel. Oh, that is a really nice thing to have happen. So now I have log of I minus log of I naught over log of 10. Oh, I know what log of 10 is. Log, that's a common log, has a base 10. The 10 is base 10. So technically, these bad boys cancel and give me 1. So I get, this is equal to log of I minus log of I naught. Ooh, I remember something. Log laws, if you have a minus, you could smush them together with a divide. So my final answer is R is the same thing as log of I over I naught. That is the same as that formula there. Wow, all that work to rewrite it as a common log. But, you know, you might have something like that in your My Math Lab. So what have we done today? We've practiced condensing, we've practiced expanding, and we've practiced just the change of base. And in this problem, we practiced all of that. So I just want you to kind of get an idea of the log laws and how we